Good morning, everyone. Welcome to the ACEEE webinar on Contracts for Difference, Driving Clean Industrial Investment. A little bit about ACEEE. The American Council for an Energy Efficient Economy is a nonpartisan research institution that develops policies that focus on combating climate change and improving energy efficiency and reducing energy waste. We are an independent organization, and our analysis has proven to advance investment programs and behaviors to use energy more effectively. My name is Pavitra Srinivasan. I'll be your host for today's webinar. I am a member of the senior research staff in the industry program, and I contributed to the report that we're going to be hearing more about today. Just an initial thought, Contracts for Differences, our report is primarily focused on materials, but it's worth remembering that it might be applicable to a number of other things and a broad range of policy applications. It can also be used to promote, for example, domestic sourcing of critical minerals. That would guarantee a purchase price that would make the difference up between current global market prices and the domestic cost of production. So that's just an example of how we could expand our thought around CfDs. A couple of housekeeping announcements as we start off. We are recording this webinar and we will be making it available to all registrants within a few business days. We will also be providing slides to all registrants. If you'd like to ask a question during the webinar, please submit it via the Q&A button at the bottom of your screen, and we will get to it during our Q&A segment towards the end of the webinar. Feel free to upvote any questions you think are particularly insightful or interesting, and we will prioritize those. Also, please feel free to chat with each other and network via the chat button that's also at the bottom of your screen. So now I'd like to turn it over to our moderator for this webinar, Dr. Neil Elliott, Director Emeritus and longtime Senior Research Director at ACEEE, who will be guiding us through the rest of this presentation and webinar. Neil, over to you.
Thank you very much, Pavitra. I'm really excited to be able to join you and talk about this, what I think is a very important topic. Chris Bataille and I were talking about early that these are ideas that have been floating around the United States, and I think we are now at a unique opportunity to begin to explore how this can be deployed domestically. To that end, the primary author of this report, and it is a cast of thousands, is Dr. Wes Look, who is affiliated with Resources for the Future. And he will go through the report, provide an overview, and then we're going to hear responses back from Brendan Larkin, who is with Congressman Paul Tonko's staff, a good friend of ACEEE, who is working on policies such as this to promote industrial clean energy. And then to get a perspective on what actually can happen in terms of actually operating these programs, we will turn to Dr. Julia Metz, who's director at Agora Industries in Germany, who can talk a little bit about how contracts for differences are being used in the EU environment and how that could be applicable to the United States. Following these presentations, we will turn to a session in which we will get a chance to hear from you as to what are your interests. Please feel free in the Q&A, as Pavitra mentioned, to direct questions specifically to any of our presenters. We are also going to be joined by three of the other co-authors, Ben Longstreet, who's a climate lawyer in this area, Dr. Bill Shobe from UVA, and Chris Bataille, who is with Columbia. All of these people bring expertise in this area, and as we see what the questions come into the Q&A, I will make a point of directing them specifically to others. I've also asked that all of the presenters and co-authors track the Q&A and respond directly to folks as those come up. And with that, I would like to turn the floor over to Wes to begin talking about what this report has been able to reveal in terms of how this could be deployed in clean industrial policy in the United States. Wes?
Thank you, Neil. One moment while I bring up the slides here. So are folks seeing my slides? No. Still not seeing them. Now seeing them.
Yes, we're seeing them now.
Yes. Okay, great. Well, good to be with everybody today. Thank you for joining. It's a pleasure to be presenting this work. As Neil mentioned, ACEEE published a report that's looking at the potential application of CfDs in the United States to support clean and competitive industry. And so I'll be giving just some snapshots from that report. We don't have a lot of time, but I want to try to share some of the key highlights. First, I want to mention that this is the product of efforts from an incredible team of colleagues. About 10 of us worked together on this report, and it's been a great process working together. So first of all, let's see, I need to move this. Okay. So I want to start just by giving us all some basics with respect to contract for differences. What are CfDs? So CfDs originated in the 1970s as a financial derivative tool traded in private markets. The way these work is they're literally a contract where one party agrees to pay the other based upon a fixed asset price, or what is often referred to as a strike price. Now, specifically, the payment is essentially the difference between the fixed price and the market price. So one party makes a payment when the market price rises above the fixed asset price, and the other party makes a payment when the market price goes below the fixed asset price. And the payment is basically the difference between the market price and the fixed asset price in all cases. One of the things that differentiates a CfD from like an options contract or a futures contract is that there's no exchange of the underlying asset. So these are fundamentally hedging instruments, or in some cases also used as speculative investment tools. In the early 2000s, CfDs began to be used as a public policy tool to promote renewable electricity, and they gained prominence in 2013 in the United Kingdom, again, with a focus on promoting renewable electricity. CfDs as public policy are also fundamentally an agreement between two parties. In this case, instead of it being two private parties trading financial derivatives, it's an agreement between the government and a producer. That could be a producer of electricity, industrial materials, etc., with the goal of promoting clean production through, again, this price guarantee. That's sort of the core feature. It's the price guarantee. So there are two primary forms of CfDs that we focus on that we think are well suited to achieving industrial decarbonization. The first is what we call a product CfD, or a PCFD, where the price guarantee reflects the price of the underlying product. So that could be a ton of steel, a ton of cement, so on. The second is a carbon CfD, or a CCFD, which is what we'll be hearing from Julia about, because that's the type of CfD that's being implemented in Germany. And here the price guarantee, or the strike price, is based upon the value of carbon emissions reduction associated with clean production. A CCFD is generally paired with a carbon market like the EU ETS. Okay. So I want to go into a little bit more detail on how these instruments work. Again, the core feature of a clean industrial CfD is the price guarantee, or again, what we refer to as the strike price. So this price guarantee, or the strike price, is the per unit price. So that would be like per ton of steel that a producer requires to manufacture the clean product. So we can think of this strike price as incorporating what is often referred to as the green premium. So let's say it costs $850 a ton of hot rolled coil steel for a steel producer to make clean steel, but HRC steel is trading in the market for $800 a ton. That strike price is set at 850. Whenever the market price is below that, the firm is going to get a subsidy effectively of about $50 per ton, that difference between the strike price and the market price. So that's sort of a simple example. Furthermore, there are two kind of breeds of this type of CFD. The first is what we call a one-sided CFD, which is very similar to a put option. And here, if the market price for the product drops below the strike price, then the government pays the difference between the market price and the strike price. So that's again that $50 if we're using this steel example of $850 for the clean steel and $800 is what's trading in the market. $50 would be what the government would pay per ton of steel. In a one-sided CFD, if the market price actually goes above 850 to let's say 875, then the firm gets to take that upside profit, the extra $25 above the strike price. They just get the entire profit. In a two-sided CFD, in the case that the market price rises above the strike price, so again, let's say it's 875, the producer actually pays the government back the difference. So they would pay the government $25 per unit in that case. It's still a valuable public policy support for the firm, but it's just not quite as lucrative for them. So we have this figure here on the bottom that sort of summarizes this. I'm not going to go through all of this in detail for the sake of time, but you can see that without any instrument, the price that the firm receives is essentially the market price is going up and down. And then in this one-sided CFD, you've got your strike price, which is this red dotted line. The market price is still fluctuating, but in any cases where the market price is below the strike price, the government pays, this is this green shaded area, the government makes the payment, that's like that $50, and so it's keeping the firm whole. And then in the cases where the market price is going above the strike price, this orange line again is the profits of the revenue realized by the producer. The producer gets to recoup that as well. In the two-sided, the payment in the upside cases goes from the firm to the government. So in our report, we focus on an industrial CFD as having three key functions. The first is to support low carbon production in cases where the technology is not yet proven or economically competitive. Now, this could be technologies that are actually not extremely innovative, but are just not yet in the money, are not yet economically competitive. So you could think of this as sort of capturing the whole array of technologies that could promote clean production, including low-hanging fruit. This could include energy efficiency, et cetera. The second is to help producers manage market risk. By having a fixed price, you're effectively managing market risk. This can bring down the cost of capital, et cetera. And then the third is actually to, in cases where we do have innovative technology, to drive innovation and demonstrations of first of a kind or nth of a kind technologies. So it can be used both for less innovative and for more innovative technology deployment. So we, in the report, sort of the main body of the report is focused on the core design elements for a CFD policy at the federal level in the United States to promote industrial decarbonization. Unfortunately, I don't have a lot of time to go through this in detail, but I'll just try to hit some key points. So the first is defining the core objectives, and referring to the previous slide, are those core objectives to deploy highly innovative technology or perhaps less innovative technology? There needs to be a definition of eligibility. So what sectors and what goods would be covered? There then needs to be specification of the underlying strike price index. So that's, are we going to look at the commodity price, so the actual market price of a ton of steel? Are we going to use some other metric? There then needs to be definition of the subsidy terms. So this sort of most prominently is the decision of doing a one-sided or a two-sided CFD. There are some other details in terms of price or payment caps and things like that that would affect the ultimate subsidy, but that needs to be specified. There's a lot of detail with respect to auction design that goes into a CFD policy. The way these policies function best is when the CFD is delivered through a competitive auction. Our colleague Bill Shobe is an auction expert, and so he's taught us all, I would say, in this research project, the nuances of auction design and how complex it is. There then would need to be a decision about whether or not to include what we refer to as non-price factors. So this is a broader social and environmental factors, inclusion of things like labor standards, environmental justice standards, and whether or not these should be requirements or bonus provisions, similar to what we have in our tax credit regime in the United States for clean electricity. So then, of course, the policymaker would need to specify emissions accounting, reporting, and verification protocols. They would need to identify the implementing agency or agencies. In the UK, the CfD program is implemented collaboratively by 4 different agencies, some of which are arm's length entities from the government. So interesting sort of universe there of questions. And then, as with any subsidy, determine questions of stackability or interaction with other subsidies. And there's a sort of an interesting discourse around legal limitations on the use of CfDs in the United States. And so policymakers should look at that. We have found that largely they don't apply to a federally issued contract for difference program. They're largely applied to limitations on the privately traded CfDs. So my last slide here, just to sort of sum up some of the main advantages and challenges of contract for differences as we see them. On the advantage side, they reduce investment risk, thereby attracting and lowering the cost of capital. They facilitate price discovery when suppliers bid for support or the CfDs in auctions. This is, I think, one of the most unique and interesting aspects that differentiates. Like, this is very similar to a production tax credit, but this price discovery element is an interesting, I think, advancement. And then they may conserve public funds compared to other financial support, specifically because of this price discovery component, and also in the case of a two-sided CfD where payments go back to the government in windfall profit cases. CfDs also do have challenges, however. They may weaken market incentives because they are a price guarantee, so firms may be a little bit less responsive to the market. They may overlook other policy concerns if they don't bring in non-price factors. So, that needs to be added deliberately. There is risk of overcompensating producers if payments are based on average prices, which they tend to be. And then because these are long-term contracts, they could reduce adaptability to market changes, and they may not be well suited for material efficiency and material substitution projects. So that's it in a snapshot. I'm going to pass the mic back to Neil, and let's see, stop sharing. How do I do that?
I'm going to turn the mic over, or the floor over, to Brendan Larkin. And Brendan, I think, as I said at the beginning, is a longtime friend of ACEEE, and he's Deputy Chief of Staff for Congressman Paul Tonko from New York. And we've had the opportunity to work with Brendan for a number of years on policies, particularly targeting the industrial sector. So Brendan, I will turn this to you and ask that you give us your thoughts on how this could be applicable here in the United States.
Great. Well, thank you very much, Neil, and ACEEE and Wes and the other authors of this report. I think it's a really great report to examine the history, the strengths, the weaknesses, and the design decisions for a CfD program. And it's a great time for people to be kind of being able to reflect on all these different tools we have in our climate and decarbonization toolkit here. But as Neil mentioned, I work for Congressman Paul Tonko. He represents a district in upstate New York that is really kind of on the eastern frontier of the Rust Belt. It has a huge manufacturing legacy along the Hudson Mohawk rivers and the Erie Canal, and that really continues to this day. So Certainly, he cares about decarbonization. He cares about ambitious climate action, but it acknowledges the importance of U.S. heavy industry and the need for these manufactured products and ultimately building climate solutions. So that's kind of why we've done a lot of work on the industrial sector in the past and hope we will continue to do so. But I think part of the reason I was maybe asked to join this discussion today is back in 2020, Congressman Tonko started working on a hydrogen contracts for differences bill that was introduced in 2021 as the Clean Hydrogen Deployment Act with David McKinley, who is a former Republican member from West Virginia. As far as I know, this was the first emissions-related CFD bill proposed in U.S. Congress. Neil may have a better history of that than me, though. So at the time we started working on this proposal, it wasn't obvious that a hydrogen production tax credit would be enacted. So I think we felt there was some space to explore an alternative incentive program for low emissions hydrogen. And we felt like a CFD could maybe fit the bill because there seemed like there was a need for both incentives on both the supply and the demand side for growing a clean hydrogen industry. And merely incentivizing production wasn't going to create that strong and sustained end market. And I think for what it's worth, some of those views were maybe validated because in the Biden administration, the Department of Energy took some money from the Hydrogen Hub program and started to stand up a demand side incentive program in 2024. So we were kind of drawn to the CFD proposal because of this, demand side encouragement, but also, we saw some estimates that the cost of low emissions hydrogen would be dropping significantly in the near future. So it seemed like a very, dynamic, fluctuating cost, and that was expected to be driven by, scaling deployment and technology improvements. So it seemed like a CFD program could help mitigate some of the risk of overcompensating suppliers. And if policymakers were to lock in a too lucrative of a credit at the start of that incentive period. So we thought that price discovery made some important contributions to a market where we didn't really have a very high degree of certainty or confidence on what future cost estimates may actually be. And so we kind of explored this policy knowing that the UK had done this for renewables. And really, I think our goal with this bill, while enactment's always great, we really wanted to try to socialize the concept here in Congress and just get people thinking about CFDs as a potential option worth exploring. And obviously, this report goes much deeper on some of these questions than what we wrestled with a few years ago. So I guess I'll just say that this is exciting time for people to start thinking about the next generation of climate legislation for people focused on congressional action. I think some of our assumptions about what makes good and coalition building policy deserve to be questioned after seeing some of the IRA incentives and programs repealed, and also seeing existing grant programs like the Industrial Demonstration Program grants potentially being canceled or at least put at risk. So I think looking forward, now's a good time to start doing this work, just as it was during the second half of the first Trump administration, when many of the ideas that became the IRA and the IIJA infrastructure law were developed. I guess I'll just close by saying I think there's a reflexive urge to do the things that have always been done in the past, and sometimes that's for good reason. These concepts are better socialized, and therefore their effects are more maybe easily understandable to impacted firms. But that doesn't mean that that's necessarily the most effective or efficient policy. So in this case, just because we've always done investment tax credits and production tax credits doesn't mean that will be the right option next time. But it also doesn't mean that it won't be the right option. And truthfully, I don't know what the best answer is. I don't know that anyone does at this point. But I am pretty confident that the next major decarbonization climate bill enacted by Congress will have a major focus on the industrial sector. So I think it's great that people use this time to start to think about those strengths and weaknesses of different policies and make sure that there are options available for policymakers when that time comes. So again, I want to just express my gratitude for the authors of the working on this, and hope that maybe it can lead to more discussions both in Congress and the broader stakeholder community. So thanks for having me.
Thanks very much, Brendan. Now we're going to move from a discussion of the theoretical and the potential to a discussion of actual program implementation with Dr. Julia Metz, who is a director at Agri Industries in Germany and has extensive experience working in EU markets on a clean energy, industrial energy transition. So, Julia, turn the floor over to you.
Yeah, thank you. Great. Thanks for the invitation. And while I'll pull up my slides, where are they? Here. I just want to also express my gratitude to ACEEE for this great report. And I must add that I think it's great that, so maybe coming with the background of coming from Germany, where institutions having energy efficiency in their title often focus rather on incremental efficiency improvements. I think it's really great that you are actually looking into policy instruments that target transformative change, transformative decarbonization. And so congratulations. I really welcome this, and I think I'm going to try to make my my statement brief, because really lots of what you mentioned, Wes, and what you cover in your study, I fully agree with many of the points you made. But what I want to do now is to briefly say something about the setup of the CfD scheme that we have in Germany, which has been introduced 2 years ago, and we had the first auction round last year. And then I'm going to focus, and then I'm going to say something about the CfDs and the policy mix. And in the end, I'm going to focus on the results of the first auction round and the first lessons learned. So as Wes already mentioned in his input, the CfD scheme in Germany, actually we always refer to CfD, so carbon contracts for difference. It's based on or has been designed in reference to the EU emission trading system. So that's why you see here on the graph where you can see, okay, how is the government subsidy calculated? You see on the left-hand side the CO2 costs from the emission trading system as a key parameter. Further basics about the scheme are that the scheme covers both CAPEX and OPEX costs. It's related to the ETS, I already mentioned this. It's based on auctions, and these contracts are being made for a duration of 15 years. So who's eligible? So what's the sectoral scope, and which country, which companies can apply? So the focus is really on the emission-intensive industry, which is covered by the emission trading system, which makes sense because that's the reference point. So, for example, this would be sectors such as paper, glass and ceramics, steel, chemicals, lime and cement, and so on. And in order to apply for such a CfDs, the companies, the project needs to guarantee that the proposed investment would lead to a reduction of 90% carbon emissions compared to a comparable conventional plant by the end of the funding period. So within 15 years. So counting from now, this would be in 2040, for example. And in addition, the first 60% of reduction need to be achieved within or after 3 years of operation, which is actually, you know, like that's where the transformative part is quite visible, I would say. And there's currently also a threshold, a minimum threshold of 10 kilotons of CO2 per year, which a project needs to, which the reference project, conventional project would emit per year. And if we look at the CfDs in the policy mix, what are their role, what are the limitations, and what does this imply for additional instruments that are needed? I think I can go through all of this quite quick because it really resembles a lot of what Wes said. So it's really the instrument is great for really the market introduction of new climate friendly technologies to compensate for possible first mover disadvantage for paying down the cost, or not, it's not yet the cost curve, but in order to compensate for this risk. And also to promote technology and innovation by funding individual projects. In turn, what are the limitations? So this is an instrument that would really address the transformation of entire sectors. And it's also not an instrument that would ensure the competitiveness or resilience to quite important buzzwords right now in Europe for the industry, of the entire industry when transitioning towards climate-friendly production. And an additional point, which really has become evident in the first auction round and the process around, is that there's no link to infrastructure development. Yeah, this is quite relevant for projects which would be based on hydrogen or would use CCS technologies and are reliant on the build out of the necessary infrastructure in order to also achieve this quite high emission reduction already within the first 3 years. So this is really, really an important point to keep in mind. So what do we need in addition? So support the infrastructure development, demand side instruments, of course, looking forward to guarantee offtake for green products. And then in order to address an entire sector, other instruments such as tax credits as CAPEX support or OPEX support for electricity price reliefs in order to incentivize electrification by closing the possible price gap between electricity and gas. Good. Now, the probably most interesting part comes now. So what are the results of the first auction? Which has been, or the results have been published. It's already almost a year ago. 15 CfDs have been signed with a volume of up to 2.8 billion euros. It says maximum volume because the CfDs are both sided. So it could be that government gets money funding back if the carbon price rises stronger than assumed when handing in the proposal or the application. And these 15 projects are expected to save up to 17 million tons of CO2 equivalents over the term of 15 years. Just as a ballpark number, right now, the industrial carbon emission, CO2 equivalent emissions in Germany are at about 160 million tons last year. So, wow, these 17 million tons would be over the period of 15 years, but just to have, you know, like a rough understanding. The sectors covered by these 15 CfDs are chemicals, pulp and paper, heat and gypsum, metals, and glass and ceramics. And the regional distribution is, of course, for policymakers in a federal state, always relevant. And these, the result has showed that the projects are spread over 7 federal states, including 2, this is a German, 2 new federal states, so of the former Eastern Germany, which is also relevant point for the political acceptability of such an instrument, which only targets individual companies. And which is what I actually found one of the most important or interesting things is to look at, okay, which technologies and energy sources have actually received funding. And here we, on the one hand side, we see a broad diversity across electricity, hydrogen, biomass, and hybrid technologies. However, really the focus of these projects has been decarbonizing industrial heat. So all 15 projects are about decarbonizing heat generation, and both for low temperatures, so in the chemicals or paper sectors, for example, to process to produce steam, and also for higher temperatures, such as in the glass and ceramics industry. And maybe for efficiency people, what's also interesting is that the technology which received or has been, how should I put it, like which has been most often applied, so 4 out of 15 projects will implement a large heat pump. And then there are also some electric boilers, hydrogen fed boilers, biomass fed boilers, and so on. But heat pumps are on the top. And with regards to hydrogen, because this is also something which is being observed quite closely, what can these CfDs also be an instrument to ramp up hydrogen? 5 of these projects, so 1/3, have proposed the use of hydrogen with a funding volume of more than 1 billion euros. So about 1/3. Okay, I have one last slide on what are the lessons learned, or what's the government currently thinking about how to further develop this scheme. One issue was to, or has been to increase the accessibility to small and medium-sized enterprises. This is something that has been criticized, that SMEs are disfavored in the policy design. A further consideration is how to increase the use of hydrogen in order to really develop this instrument into a tool to ramp up hydrogen as a, from the demand side. Opening up the instrument to CCU and CCS technologies. Actually, this is the intended focus for the second round of auctions currently prepared by government. And then in the instrument design to increase flexibility, because there has been the accusation that the instrument is quite, complicated to deal with from a company perspective. And lastly, to extend it to steam production, as the steam production needs to be connected to industrial production, but nonetheless to have steam production as an eligible product actually covered by the scheme. Okay, and now I'm finished with my presentation.
Thank you so much, Julia. Fascinating discussions here. And Julia, I'm very pleased to hear that industrial heat and heat pumps are there, since I've spent close to 40 years of my career advocating for them. So a couple of questions have come in, and I'll turn the first one to Julia, if you will look in the Q&A. What is the future of the auction? Was it competitive, and what do you see the changes in the next round of auction for the CfDs?
So for the next round of auction, as I just mentioned, in my view, so I'm not into in my team, I have people like working on the technical details of this. I look at this more from a political perspective, and what's the, and how far does the instrument serve the needs for the industrial transition. And in my view, the scope of the second auction is quite different than the first, because it has such a specific focus on CCS and CCU. And on the so it's difficult to compare, I would guess. But in terms of competitiveness, what I've heard actually, because the government does a first round of in German Interessensbekundung. So companies that are interested in applying, it's a how do you say, like, it's not really a pre-application, but it's like a
vetting, like a vetting.
Okay, good. Perfect.
Yeah.
Thank you. And here for the CCS round, a large interest has been registered. I would need to look up the exact numbers, but yeah.
Great. So another question we've gotten, or I guess really two questions that are sort of interrelated, is CfDs have the potential to distort the market and promote substandard or immature products and services. Maybe I'll turn to Wes and then to Chris to sort of say, how do you see being able to address those concerns?
Well, I'll just start by saying, and please do jump in here, Chris. I'll start by saying that I think CfDs actually are very well suited to achieving what I do think is a very important public policy function, which is to promote underdeveloped technologies. We, I think, clearly know both from economics literature that there's a market failure around research and development in private markets. and so there is a legitimate role for government that I think is widely viewed from a bipartisan perspective as a legitimate role in the United States to promote innovative technology. And I think that CfDs actually do that well, partially because they manage risk. And so some of how the policy functions, you almost have like a loan guarantee built in with a grant, in that the government is providing some risk mitigation. And then the value that transfers to the company of risk mitigation actually comes through private capital. So the private capital, that value is the effect of reducing the cost of capital because the risk has been reduced. So now the firm can attract capital at a lower cost. So there's less government on the hook for the benefit that accrues to the project to support innovation. The other thing I would say is with the two-sided instrument on a windfall side, so if an innovative technology does really well and the market develops in a way where it can make windfall profits, then the government is going to not be over subsidizing, which is potential with innovative projects as well, because there's just a lot of uncertainty. So Brendan spoke a little bit to that. But let me pause there, and Chris, I'd love to hear your thoughts on this as well.
Yeah, no, I was just going to pick up on the element of price discovery, right? Because in the U.S., there's been a history of offering fixed ITCs or fixed PTCs, which has required a lot of pre-analysis to try and get right. And the problem is it can err on the low side where it's not enough to get the job done, but it can also err on the high side, which means that companies get more than is necessary, and it's not preserving public funds. So you're missing the efficiency element, and you're not conserving public funds. But the beauty of the CfD in a certain way is you go to market saying you want this much mitigation, you want this many first of a kind plants, and companies tell you what that's going to take. And speaking what Julia was just referring to, the vetting stage is first you sort for companies that are real, that aren't going to, they're not going to lowball you and then not deliver. You're looking for companies that deliver. Then you're looking for ones that can do it at the least cost. So a key element that these CfDs introduce going into the future for the U.S. is this idea of price discovery and minimizing the use of public funds. Neil was just mentioning the competitiveness aspect. We have to remember that this is occurring within the environment of the entire EU gradually moving to border carbon adjustments, right? So they're gradually getting rid of the free permit allocations that are being given to heavy industry and replacing those with border carbon adjustments. Now that's an evolving picture, and the U.S. has its own discussion relative to that, and an American CfD program would have to kind of sit within whatever bills emerge in terms of border carbon adjustments for the U.S.
Wanted to pick up on one of the points that Julia made, and that is that the CfD is important to address as a part of a portfolio of policies to address certain market failures or distortions in there. I did want to pick up because one of the things we discovered in the United States, and I'd love to hear from Brendan on this one, is the question of the need to also have policies in place that promote the development of the infrastructure. And in the United States, I think infrastructure, one of the things that we see or have seen in the United States has been availability of low carbon electricity and the absence of sufficient policies to address that. Brendan, you want to respond, and then maybe Wes or Chris are welcome to weigh in as well.
Yeah, I think just both the political realities of our system, but also probably, frankly, the needs require those sorts of a portfolio of incentives and programs, and to try to really transition to a decarbonized economy. And certainly on the infrastructure side, this is something we wrestled with, and trying to figure out how, in the pilot program that Mr. Tonko's bill proposes, like how can those infrastructure investments potentially be included and compensated as part of a CfD and project development, but also that may be limited to the infrastructure and the capital expenditures that are needed, like within the fence line of a facility, and don't necessarily account for the hydrogen pipeline that's going to bring the hydrogen there, or the access to low cost clean electricity coming off the grid. So I think there probably do need to be interventions, targeted interventions across a whole lot of different aspects of the economy to make this work. Mr. Tonko also supports a national American ETS and a border adjustment to go with that, but we're clearly missing many of the puzzle pieces that the EU has either already figured out or are currently working off of to build the CfD program as just one pillar of.
Wes, Chris, thoughts on this issue?
One thing Wes and I was just discussing this. a key element of the German program is that there are adjustments within the German CfD program for gas and electricity prices, right? So as gas goes up and down, or key inputs to whatever industrial process we're talking about, as that goes up and down, the CfD goes up and down, and something similar would need to be put, would likely be useful in a US context as well. Wes, I don't know if there's anything you want to add to that.
No, I think that that covers it well. I mean, and on this piece about a variety of policies, I agree with Brendan that we do need a heterogeneity of policies. I don't know that CFDs are going to be a silver bullet. And actually, Julia, I'd be interested to hear more if you're willing to. It wasn't a huge focus in your presentation about how this is done in Germany, how the CFD program interacts with other subsidy programs in particular. I think it's very clear how it interacts with the ETS, but in my mind, it effectively allows for other subsidies to be in place, but it sort of factors those in, and in that way, I think serves an interesting like top up function, um, both in the context of the ETS and in the context of additional subsidies. Could you speak just a little bit about how that works in Germany?
Yeah, so in part, it's the way you described it. So it works together with some other funding instruments, but not with all. And that is one of the key reasons why we haven't seen any steel companies receiving a CfD, because the large steel producers in Germany have already received a subsidy under a European funding scheme, the so-called IPCEI project, integrated projects of common European interests, something. Yeah. So a European funding scheme, and so and here, like an additional subsidy through the CfDs has been excluded. So it works in part, but for these large. And in Germany, we also have another large funding stream for CAPEX investments, the federal funding program for industrial decarbonization. And here, combining both is also excluded. Yeah, so it's in part true, but I think it's important to have in mind, because that this has been a reason for why steel companies have not applied for the CfDs. Because when we started working on CfDs 5 years ago, I think, our focus has really been on, we started with a focus on steel making, and then we developed a specific proposal also for the cement industry. But actually, like these big facilities and production plants had originally been the focus in our work, how we designed a proposal initially.
So if I can turn to Bill Shobe on a question, as you think of the auction designs, do we need to be thinking in terms of actually multiple auctions for different markets?
Yeah, so there was a question floating around about this. If you're taking bids from different companies and then sorting the bids, so you have this pre-qualification process. So you have firms you think can reliably accomplish the end goal. You're going to take the bids and sort them by the cost from low to high, and then accept those lowest bids. And at any point in time, generally speaking, you're probably going to have a group of bids from the most mature, the most ready to implement technology, and the more innovative, riskier technologies probably would end up with higher strike price bids. And so, if you wanted to have a broad representation of different technologies, if you want steel and cement and petrochemicals, probably you have to provide separate opportunities for bidding. It doesn't mean you get the lowest cost for CO2 in the short run, but your goal is to induce innovation in the long run. And it may be that to do that, you have to separate out the auctions.
Yeah, and I think, just to that point, Bill, if we can probe a little, if I may probe a little further on, we also may be talking about different technology maturities,
Yeah.
dealing with a technology like hydrogen DRI, which I know works. I can say that with great confidence, versus something more like a electric cracker in ethylene production facility, which not sure it really works. We're still waiting to find out. So
Right. Well, so this is what the CFD is for, right? It's to try to reduce the risk exposure to risky new technologies. The problem we have is that if you one of the things you need in an auction is you need significant participation, so you have some competitive price discovery. If you only have one or two people, if you only have a couple of firms bidding, you're going to get less good price discovery than if you have a larger number. And the more you break the sectors up into smaller and smaller groups so that you're addressing innovativeness and you're addressing maturity and all these things, you tend to get a smaller number of bidders in the auction. And so you have to face this trade-off that the more you divide the population of bidders up into different groups so that you have wider representation across industries and across maturities, the more likely you are to have smaller numbers. And so you have to think about making sure that whatever procurement mechanism you choose has to be chosen accordingly, because you have some procurement auction designs are going to work better with smaller numbers of bidders, and some will work better if you have wider representation and more bidders.
great. Well, I wish we could continue this. I can think of so many questions that I would love to continue to probe on this, but we are closing to approaching time. So I want to turn this back over to my colleague, Dr. Srinivasan, to close us out, and welcome continued dialogue. Please reach out to ACEEE or the report authors as we continue this discussion. Pavitra? Yeah. There we go.
Aha, there we go. All right. Well, just like to echo what Neil said. I'd like to thank all the presenters and all the report co-authors who shared their valuable time today and responded to the questions. Please feel free to reach out separately via email. You can either reach out to Wes Look or to Richard Hart with additional questions, and we're happy to engage in further discussion on these issues. Just a little bit on upcoming conferences that ACEEE has. Please take a look at our conference's website and do join us if you can at any of these events. And I'd just like to close by thanking everyone. So with this, we're going to be closing the webinar. Thank you for attending today.